Hi, can we start now or still more people to join?
Yes, sir. You can start now. Archana,
Yes, sir.
you
Yes, sir.
please introduce, sir. Then.
A very good evening to one and all. Welcome to day 5, ninth technical session of 6-day online faculty development program on recent advancement in e-mobility for developing power utility sponsored by AICTE ATAL. Our today's resource person of this session is Chiro Bhaumik, Chirabrata Bhaumik, sir, sorry. On behalf of organizing team, I welcome you, sir, in our today's technical session. Before you start your expert lecture, I would like to share your short biography with the participants. Chirabrata Bhaumik is a principal scientist in TCS research under the Embedded Device and Intelligent Service System Research area. He received BE degree in electrical engineering from BE College, currently known as IIEST Sipur, and MS degree in software system from BITS Pilani. He has more than 25 years of experience in embedded system domain. His current area of research in innovative sensing in machine, material, and infrastructure sensing. Prior to TCS, he was with HCL, Infosys Limited, BFL, Software Limited, and Rebecca. He holds more than 80 patents in geographies like USA, European Union, India, and Australia, and has over 70 publications in various international conferences and journals. He is a senior member of IEEE. With this, I would request our expert, Chirabrata Bhaumik sir, to kindly enlighten us with his words of wisdom. Sir, please.
Yeah. Hi. Thanks for the introduction. Uh, Good evening, all. I will talk on the challenges of smart manufacturing. Today it is everywhere you see IoT, Industry 4.0, smart manufacturing, and all. So, but it has its own challenges, and it is going to be more challenging in the future because of new technologies like Gen AI and all. So, I will try to present the work, the researches we are doing in smart manufacturing, and how is it changing the manufacturing industry, and how various manufacturing industries in various domains, how are they trying to tackle, and what is the future hold for us. I will mainly talk about the research challenges, and will try to give a glimpse, and maybe this will be food for thought of you guys to do more research on that and make solutions, and then take it ahead. I will try to present my uh, PPT. Just let me know when it's viewable. Yeah. Yes. Is my screen visible?
Yes, sir.
Okay. Let me. Yeah. You are seeing full screen?
Yes, sir.
Okay. Okay. Then I'm little bit like with Microsoft Teams and Webex. I'm here little not bit conversant with Google
Yes.
Meet that much, but okay. Anyway, yeah. Okay. So okay. I will stop my video. Then maybe it will be better. Wait, no, no, stop sharing. Okay. Okay. Let the video be on. Okay. So I will talk about the future of smart manufacturing, the challenges we are going to face, and what it holds for us. So, first, I will try to give a glimpse of the challenges the manufacturing companies are facing today in the real industry. So, so real life, what are the challenges? So people will say you like today, IoT is there, you have sensors everywhere, you have 5G, 6G is coming, so communication is no issue. So you just put sensors, get data from all your machines, crunch those data, feed it to AI, and then you have everything. But in real life, that's not the case, because this in real life factories, they have to balance. They are all legacy machines, and they are performing for over 60, 70 years. You go to companies like Tata Steel, Tata Power, and you will see their machines which are more than 50, 60, 70 years old, and they are still running good. So why somebody is going to throw it out? So there are these legacy machines which are working perfectly. Then you have some machines which have become obsolete, but you are not able to throw them out. And then you are having your modern day equipments, which is coming fitted with all your sensors, and those sensors data are going to cloud or going to edge, and you are able to data crunch, you are able to see. So you have to make a balance of everything. So that's the real life challenge today. So what does this mean actually for real enterprises? That means you cannot do a complete overhaul. You cannot say I stop this whole thing and I start from zero. No, it's not possible, because the cost is one of the reason. Cost is like, it's not feasible that you throw out every of your investment and you start totally fresh. So you have to have equipment obsolescence strategy. And then I will talk of one of the main issues, like traditionally in factories, what like you will see the two silos, like the factory machines, they are under your operations divisions, so they are OT data, whereas real factory, which is having your production data, your quality output and all, they are in your ERP and all, that is your IT data. So and these IT and OT data, they don't talk, they're totally divergent. So they are creating actually these data silos. So these are actual real life challenges, and we have to solve this. So what I have told you, that like in manufacturing industry, there are obsolete, like they are legacy machines, they're outdated, functional. Of system, there are obsolete machines which are like, people like maybe, yeah, the manager has written it off, but it is in process of becoming outdated. And then the new equipments have come with latest development. So, but in real life, when we have actually talked to various big manufacturing companies in domains, steel and pharmaceutical, huge portion of them is following in this legacy or obsolete category. So, so these are the things, somehow you have to bring them into the smart manufacturing domain. That's one of the main challenge. And they lack a flexibility there, and they're not compatible with new technologies. So this is what is creating what we are calling siloed system. So you have data silos. So these machines, which are old machines, which we, even if when they generate data, they are remain locked within their own ecosystem. Like you have a cold press, you have a pressing machine, and that data output. So how is this machine and all that? It is nowhere visible in your whole IT system. And there is a famous like challenge, whoever like us who are working in this field, known as Conway's law. Like it is what it tells is the software systems that reflect your reflect your communication structure. So how you like, if you if yeah if your thing is mainly OT oriented, then your system will be also like what you call like all silos. There will be a department which works with their own software, then another department own works, but no way they talk with each other. So these are the problems we need to solve. We need to what you call a unified strategy to bring them all under one umbrella and take values out of it. So this is what IT and OT systems are. There's a disconnect coming. Your IT systems is all talking about like how you manage and govern process. So when we talk of IT systems, we are talking of your KPIs, your key performance indicators, how coordinate resources. But when you say talk of OT systems, the OT systems just talk about like how to execute this process. Like if you want to make this output, you have to run this machine in this fashion, ABCD, for so many hours, and then you get it. So that is OT. So whatever, if you have to do something change, your PLC or sensor needs to change, you have to tune some parameter to make it work, but that doesn't get reflected in overall IT systems. So this IT OT divergence happens, and OT systems traditionally are very closed environment. It generally deals with your embedded systems. It works on, mostly you will see which are old, like 20, 30 years old, they will work on your RS485 serial ports and all. The new ones will come with Ethernet interface, and they will have the backplane where you can take those data to your ERP. But old ones which are still work, you will see like they are working. You have some industrial PC, some console stuck at some places, and then it is communicating over serial port, getting the data, and whoever is supervisor of that OT system, he's pretty happy with that. They know that system inside out, and they are giving the output perfectly. But somehow the whole company from a higher point of view, they are not getting the max output from the investment they are giving. So theoretically, your best solution, yes, what we call is greenfield transformation. You just whatever you have, throw it out. You invest in totally a new factory with all new sensors and all. That will give you the maximum output. But that's not practical, because the financial investment will be huge, enormous. There are like an automobile equipment, or let's say steel factory equipment. Like the assets are built, which has to like, when they are built, they have been designed to build to last for decades. When you make a boiler, you cannot throw it out just after 2 3 years. It is like it should support 20 30 years. And also, if you want to make a new uh, like these big factories, it will for extended period you have to stop your production. This is not a practical solution. So what is practical? So that is the research challenge, and we are calling it's the next generation. Like, you have to inject new capability in your existing production line. So you have to integrate the modern technologies, your existing manufacturing, progressively. You cannot like just on a day, you cannot put sensors everywhere and modernize with complete replacement. So you have to gradually infuse the newer technologies. So whatever you have to talk with your vendor, whatever sensors are possible, you have to you have to put those sensors, get those sensor data into an IoT platform, and then get whatever, like your applications, or you have to get that view. Like, so from the machines. You get the vibration data, you get the heat map data, and then you have to form your predictive maintenance, so that from the heat and the vibration you can understand how the ball bearings are behaving, how your total machine is behaving. You can strategize your predictive maintenance schedule accordingly. And gradually, like, modern technology means AI is going to come. AI has to be deployed. So, and it has to be AI driven automation. It cannot be like a human driven automation. So you have to have strategies by where these data need to be pumped with certain kind of level, supervised, non-supervised, and then your data technologies should gradually take over to drive the automation. They should take decisions instead of all the time you have to wait for a skilled worker to take decisions. You have to gradually put these decisions to a computing platform who will as soon as you give them more data, and it is going to take intelligent and correct decisions based on yeah, your vision, what you want output. And always, like, it cannot be silos and all. There has to be some kind of cloud. It can be your on-premise cloud, like if you have issues with security or existing or taking it to public platform, you have to have private cloud, or that's like up to your own security strategy on whether it's a public cloud or a private cloud. It has to be a cloud friendly technologies should come. And the whole next gen manufacturing technology should be designed such that it has to evolve because there will be new technologies coming. You cannot predict everything what is going to come. So you cannot be what you call too much strict and stick to something. You have to be adaptable. So whatever new technologies come, you have to take that in stride and use that. So it has to be adaptable to future needs. So this is the real ask of the future, and it's not easy. But when you do all these things, there will be challenges, and these are actually the research challenges. You should, like, based on your domain, your like and all, you should feel the similar as you are now going to expose your OT data into outer world, into the into the internet, in your clouds. Cybersecurity is one of the biggest issues. There will be increased attack because when your all your all your factories are connected, equipments are connected, there will be there may be, like, if you are not careful enough, and if not take proper technology, there will be a larger attack, and somebody will take hold of the weak links there, and may attack your machines and hold ransom. So cybersecurity is one of the biggest threat. There will be data breach, like your data may get leaked to somewhere, and it can be misused. So sensitive data, like how your sensitive machines are performing, what is your, so these things can get exposed. So you have to take proper you have to take proper measures to hold that. And ransomware attack already, like last I think 2023-24, we have like 5 to 6 big cybersecurity attacks have taken place using OT data. The famous one is like Tata Power has been hold ransom for, I mean, I think almost 1 to 2 day. Toyota's US factory has been attacked a lot, and then other big things were also there. And most of the cases, it was some vulnerability in some small machines. These attackers have taken hold of, and then they hold these ransom attacks. So cybersecurity is going to be one of the biggest challenge. Then your data, since now gradually you are putting sensors everywhere, so there will be huge data. So this data management and integration will be one of the biggest challenges. which we have to solve such challenge. So there will be like the data will be of various type. There is no defined machines will create. So all this data will be created in various silos. So there will be too much. There will be problem with data quality. Some data will get mixed up. Then there will be wrong data. Then there will be data overload. So these are the like while your AI engines has to take decisions. So this you have to understand in your pre-processing layer, and you have to take these challenges and and solve this problem. So there will be a huge scope of work in the research challenges in this data management and integration. Whenever we have talk of next generation smart manufacturing. Then obviously like which maybe as a research thing we don't may not have to take care, but there will be skill gap. There will be, because newer technologies coming, there will be lack of skilled workers. And so you have to, it is more of a HR issue, like you have to reskill your existing workforce so with new technologies. So that will be one of the challenge when you see from a bigger perspective, from a factory point of view. Then since there will be so many systems, now it is real system of systems working, so there will be integration, interoperability issues, compatibility issues, and legacy. Like I have told, like bringing legacy systems into smart manufacturing is one of the biggest challenge people have to solve to make this next generation manufacturing technology work. And obviously ethical considerations are there. And this like maybe the like with this slide maybe I will stop and take your questions. So this is our view. Actually the whole thing, next generation manufacturing, is going to actually look like this. So at the lowest layer, at the this lowest layer, you have the manufacturing units in various domains. So since you guys are mainly talking of automotive technology, EV battery and all this, so this will be your automotive domains. Then there's a big chunk of factories there in pharma and chemical domain. Then you have oil and gas, and then FMCG companies are there. Then logistics and shipping companies are there. So all these manufacturing units have their factories, and at their shop floor you have all this kind of, for automation you have the PLCs, industrial automation. Gradually there will be more robots and motion controls will be there. Then like robot and human have to coexist. You have to have so many sensors, and since you have PLC and your older systems will have their SCADA and HMI, you cannot escape out of. So your SCADA systems and old HMI system will be there, and there will be specialized devices. So when you are working with so many things in OT, so there will be actually in the shop floor when you are going for a software layer architecture, you will see like there like you will get bombarded with so many kinds of protocols. There will be HTTP, then your older Modbus, OPC UA, then you will have your Siemens PLC devices for S7, then Rockwell. There's so many kinds of PLCs will propinate. The newer sensors will come with your MQTT and DDS protocol. Then for automotive, there will be CAN bus. For compressors, chillers, there will be backnet. So, and for all your streaming capabilities, you will have RTP, RTSP, ONBF protocol. So there will be so many kinds of protocols that need to be handled at OT layers. And then what we are visionaries, and like at TCS, we are trying to make a unified platform. What we view like where like you have to have provisions for AI in every domain. So at the uppermost layer, you will have various applications which are AI driven apps. So, but everybody will actually take help. So the main intelligence will be at this unified platform, by which actually all these applications will take this intelligence and push like for more automation to take decisions. So this is like actually your like your future smart manufacturing facilities will look like. I think I will stop here and I can take any question now if you.
My question is that, sir, how PLC is affected for that?
Can you come
That
again?
you have to clear me. About PLC.
Ah,
How the
yes.
PLC automation is helpful for that?
See, PLC automation. See, PLCs currently, if you see the problem in PLCs, like the Siemens PLCs are going to talk only with S7 or whatever protocol, and it is not going to talk with Rockwell PLC. So maybe when PLC, like we are working on a concept called virtual PLC, a software PLC. So maybe like a layer above this today's PLCs, there has to be a layer getting developed, which has to take work as a master PLC and making these existing PLC as slave PLC. So one way it is going to take the inputs from the existing PLCs and then maybe forward to upper layer. Make it may be your OPCUA protocol or some kind of protocol like that, where you push that and then whatever it transfers, your AI takes decisions to tell you to tell, like, okay, you change the temperature to this. Then basically it should go back, and the virtual PLC should tell the slave PLC to work at that level. So that way you have to have some kind of a layer. The virtual PLC, you have to make the virtual PLC to solve that. That's the way we are trying to solve it.
The problem is existing with the PLC that every company have a different software.
Yes, yes, but
And with the coordinate with the because in my lab
mm,
there is Mitsubishi, Simpson,
yes,
every lab, every PLC we have used.
mm,
Okay, so that is the biggest problem, that to coordinate with all the PLC with the different language with different programming. That is the biggest problem to us.
yeah.
How to overcome that?
See, one of the issues, like, see, most of the students, like, if they talk OPCUA, then you actually can talk OPCUA and can solve this. But many of these which are not talk OPCUA also. If it is OPCUA, most of your, like, Siemens, Rockwell, Mitsubishi, Emerson, Fanuc, everybody talks OPCUA. So you can solve it in the OPCUA layer.
Okay, thank you, sir.
Any more question?
Dear participant, if you have any question or queries, you can ask.
I think someone has raised a hand, like Megha. If you can.
No, sir, go ahead. Mega have already have hand off from last 3 days. So go ahead. I am listening that Mega name from last 4 days. So go ahead, sir. Please, sir, continue.
I think I have been, like, if you have any queries, I will take. Otherwise, that was my thing.
Definitely, I put the question from you, my side from you.
Sir, there is no question. I think, sir, you can continue your session.
No, that's okay. Like, I think, like, that was my presentation. I'm saying that's why.
The biggest problem is that, na, sir. Now,
Yeah.
while I'm Dr. Vivek from BRCM College of Engineering. It is under MDU. The biggest problem is that they are making on the system and they are going away. They are not listening. So they, if you are asking the question, they won't reply that. What is the question? That is the attitude of the person.
So see, that's why, like, That's why, like what you like, you have to like do some research. You can search on this. There's some concept called virtual PLC is coming a lot. So there is a way like to some extent you can solve with Node-RED. If you see Node-RED has like what you call has the protocols, let's say for Profinet, for S7, for Micrologics, so for Mitsubishi, for Snyder. So if you can make your Node-RED work, it can also talk Modbus TCP. So one of the way you can solve, like maybe your whole thing will you have to develop some more. So like a Node-RED, or you have to Node-RED is like if you want to do a no coding kind of thing, Node-RED can be a very good platform which you can look at and see. It can be one of your mediator. So one hand it can talk with all your PLCs, or it can talk over serial port or your Ethernet, and you can have your OPC server where you push that, and so that can be one of the mediator. Or there's a you can search on also virtual PLC. So you people, there are many what you call research works going on making this virtual. It's not a solved problem. It's like
Thank you, sir. That the thing is that my opinion is that if organizer with things like that, if suppose if somebody is taking online classes or some reputed person is taking online classes, there must be a how to the other are involved in this measurement must be there. Somebody will be measured the person is there existing or not, or only they are making on the system and they are run away. That have to be taken care by the organization committee.
see, if a vendor like give you a PLC and run away, you cannot do anything. You have to change the vendor. You have to work with some other PLC. That you cannot solve, but you can make it work actually. That's one of the like. That's why like these guys, they understand like my protocol. I only understand, and somehow this what I've seen is this factory level, like people are very what you call rigid. They like, if I believe in a Siemens PLC, I am going to, I know only Siemens works. It's not like that. The other thing also works, but nobody like nowadays, like since you are from academic background, you know, like Arduino PLCs are working very good. But when you talk to an established shop floor, they will say, "Oh, Arduino, that's open source, so we don't yeah, invest on all those things." So that is the attitude problem. Maybe given time, gradually that will go.
Sorry, sir. Please continue.
No, no, I'm continuing. Like this Arduino PLCs is one of the thing you can look, which is solved. Like Open PLC is another stuff from the open source. So these are very good PLC things, which gradually, if people use them, then the PLC market will become more like a open source market today, and many of the problems what you are talking may get solved.
Okay, thank you, sir, so much, sir, for an informative and engaging session. Your expertise has added immense value to our understanding. Participants, we will meet at 7:30 for the next session.
Okay, thank you.
Thank you, sir.
Dear participant, next session will start at 7:30.
7:30, sir.
Yes, sir. We will start at 7:30.
Okay, okay, ma'am.
Okay, sir.